Good everyone, for this video, we'll be discussing about the chemical properties of lubricants. So the first chemical property of lubricant would be our viscosity index, or VI. It is a measure of the change in viscosity of a fluid, typically lubricating oil with temperature. So viscosity index is actually temperature dependent. It's particularly important in marine operations where engines, gears, and other machinery are subjected to varying temperatures due to the changing environmental conditions at sea. So therefore, it is also very important for us as engineers to determine the viscosity index of our lube oil or lubricants in order for us to determine whether they can survive higher temperature or lower temperature, or at least we can detect their limits. So according to this table 1, ISO designations for lubricating oils, we have different ISO grades. So we have 32, 46, 68, 100, 150, 220, and their equivalent viscosity at this particular temperature at 40 degrees Celsius. Say for example, if you will have your ISO grade 32, the viscosity at 40 degrees is approximately 32 degrees. And at 100 degrees Celsius, you can see here that the viscosity actually lowers down to 5.4. If we will also check ISO grade 100, this is also equivalent SAE grade, or what about SAE? This is Society of Automotive Engineers. ISO grade 100 is equivalent to SAE grade 30. And as you've noticed, the viscosity at 100 at 40 degrees Celsius, normal temperature, operating temperature is 100 also, but the viscosity at 100 degrees Celsius becomes lower at 11.4. And lastly, if you will examine the ISO grade 220, it is equivalent to SAE grade 50, in this case, 50. And the maximum viscosity at 40 degrees Celsius is also 220, as you can see here at the last row, column 3 of the table. And at 100 degrees Celsius, this viscosity lowers down to 19.4. So, as we've discussed earlier from our previous discussion, please take note that as we increase the temperature, our viscosity increases. Sorry, as we increase the temperature, the viscosity of our fuel or lube oil actually decreases. So we can see here the trend. VG, or viscosity grade, guidelines published by the International Standards Organization, ISO, use temperatures of 40 degrees to measure the viscosity of lubricants. The grading system rates oils and lubricants on a scale of ISO VG2 to ISO viscosity grade 1500, with a lower number indicating a lower viscosity index. So take note, if we have a viscosity grade which is lower, it also has lower viscosity index. If we have higher viscosity grade, so for example 1500, it is actually considered as having a higher viscosity index. So we will examine here that, for example, we'll have ISO VG2. The midpoint kinematic viscosity at 40 degrees Celsius is 2.2. And the minimum for it will be 1.98. And the maximum in this case will be 2.42. Take note, if you will be asking me how to solve for the midpoint, simply add the two, the minimum and the maximum, equals, and then divide it by 2. That's your midpoint. Let's examine VG22, ISO VG22, which is actually equivalent to the midpoint of 22. And what is the maximum and the minimum for this viscosity grade 22? The minimum grade is, or in temperature, viscosity temperature, or viscosity's particular temperature is 19.8. And the maximum would be 24.2. So again, to solve for the midpoint, we just simply add the maximum and the minimum and then divide it by 2. Last, If we have ISO viscosity grade 320, that would be our midpoint kinematic viscosity, which is also 320. And the minimum viscosity at 40 degrees Celsius would be 288, and the maximum would be 352. So this is how you interpret the table. But always remember that whatever number is written here for your viscosity grade, that is actually the midpoint kinematic viscosity, having its having its maximum point kinematic viscosity and the minimum kinematic viscosity. Chemical stability would be the next chemical property of our lube oil or lubricants. Lubricating oils with good chemical stability shouldn't be at risk of oxidizing. Generally, they are stable. They are not easily corroded or easily oxidized, carbonizing, or undergoing other undesirable reactions when exposed to oxygen. A variety of factors determine the chemical stability of a lubricant, including concentrations of catalysts such as your copper. So these are some of the evidences that our lube oil or lubricants are actually now in their decomposition state or they are gradually deteriorating. Take note of these factors. We have foul odor. So we can usually smell a bad odor or foul odor from our lubricant if they are already used or oxidized. We also see that they are darkening. Usually, when we change our oil, the color would be darker, brownish or chocolate brown, or at times really color black. We also have here the infrared spectroscopy indicating that we have oxidation. The viscosity usually increases for this particular diagram, and the acid number also increases. So therefore, this particular lube oil or lubricant will now have the tendency to corrode any metals that it passes through. Instead of helping the particular system to helping the particular system in order for it to stop corrosion, it will now actually be the one that could cause the corrosion of our metals. Lubricant oxidation is the most predominant reaction of a lubricant in service. It is responsible for numerous lubricant problems, including viscosity increase, varnish, sludge and sediment formation, additive depletion, base oil breakdown, filter clogging, loss in foam control, acid number increase, so higher acid number, that means also lower base number, rust formation, and corrosion. As you can see here, the before and after, our viscosity here is actually lower. And as you can see, upon changing your oil, the viscosity now thickens or the viscosity is increasing as evidenced here. Demulsibility, like for example, we were able to discuss last time the demulsifier as an additive agent to our lube oil. Now let's discuss about demulsibility. What is this? Demulsibility describes the ability of a lubricant to separate from water. Take note, separate from water, meaning they're not forming emulsions here if we have demulsibility. Oils with high demulsibility are generally preferred as water can compromise the lubricating properties of a product. So if I've asked you last time whether demulsibility is good or bad, actually having demulsibility which is higher is actually good for our system. That only means that your water and your oil will never mix, whatever you do to it. That's why after shaking, you can see that the oil is actually on top and the water is at the bottom. Now, what will happen if there is no demulsibility or there will be no demulsifying agent, as we discussed in additives last time? Here, with demulsibility or demulsifying agent, we can see that the oil separates from water. However, if there is lower demulsibility or no demulsibility at all, the tendency would be your oil and water will partially mix. into a suspension we call as your emulsion. It is a colloidal system wherein your liquid is being shocked into another liquid. You stir this up, or yeah, you stir it up, and actually after some time they will mix. So that is the disadvantage if we have lower demulsibility or no demulsibility at all. This can lead to issues such as increased energy consumption due to resistance, surface corrosion, of course, and contamination caused by the release of abrasive wear particles. Additives can be a good way to improve the emulsibility of a lubricant and prevent it from mixing with water. As much as possible, we don't like water in our system, especially if it's a lubricating oil system, since we must prevent corrosion and other contamination. Now, oxidation stability. Oxidation is a chemical reaction that occurs when oxygen interacts with the lubricant. Take note again, just like your chemical stability earlier, this is focused on oxygen. Variables such as water, acids, catalysts, and temperature can influence oxidation and have a negative impact on the lifespan and performance characteristics of a lubricant. So these are all causing corrosion or deterioration in our system because it will actually introduce free radicals in our system that could degrade the quality of our oil. And we don't like it because it will shorten the lifespan of our lubricant in operation. It's a waste of money actually. And there will be a tendency of damage in our system. For applications where lubricant is in circulation for long periods without being changed, such as large mechanical systems, good oxidation stability is very essential. As much as possible, to limit changing oils from time to time, we must make sure that our oil or lubricants have higher oxidation stability, meaning it will not be easily corroded or contaminated or oxidized. Corrosion resistance follows through. Corrosion occurs when electrochemical reactions takes place on a refined metal. This reaction gradually deteriorates the surface and converts the refined metal back to a more stable form such as oxide, sulfide, carbonate, or hydroxide. So again, the main goal of this, just like the anti-corrosion additive that we've discussed in the earlier video, talk about corrosion resistance, the main goal is simply to reduce the incidence of corrosion in our metal surfaces. So this is actually an experiment done, no weight loss in grams over time with different samples. For example, you've noticed here if you have hydrochloric acid, which is in sky blue, increases the corrosion of our material. Therefore, when your oil contains acid, the tendency would be corrosion will be of higher weight loss, meaning it will damage more the system. If we have here, or comparing your salt water, which is orange or yellow, with fresh water, which is blue, as you can see, the corrosion will be faster with seawater. And after some time, they will remain the same. They will be in equilibrium with the fresh water. So therefore, it is also good to treat fresh water before we use it in our operation. Okay, so this is just an illustration of how corrosion works. It actually decomposes the particular metal or system where these particular chemicals are being introduced. Base number. The total base number or base number is a measure of the alkalinity of lube oil. Take note, alkalinity. Alkalinity is actually the opposite of acidity. So therefore, as much as possible, if we will try to decide, we must make sure that we have higher base number in order for us to neutralize more acids in our system. so that our system will not be easily oxidized or corroded after some time. This plays a critical role in neutralizing acidic effects on sulfuric byproducts of fuel oil. Marine fuel have high sulfur content. We've discussed this one already in our fuel video, but it is now limited to 0.5% from according to Marpol in the year 2020 after the pandemic. The higher the base number of the lube oil, the more acid it will be able to neutralize. So if we need to decide as much as possible, we wanted to have higher base number so that we'll have higher amount of acid to be neutralized in our system. This helps improve the viscosity coefficient, fight corrosion, and resist oxidation. Thus, base number is one of such lube oil properties that directly affects the engine performance and its life. Modern marine engines run on base number 30, 40, or 50 for low sulfur oil, while for higher sulfur oil, they used to run on base number 70 or 100. The PBM for lube oil decreases with use and needs to be changed when falls below a limit. So, since we are dealing here with neutralization, once more base is being neutralized by the acid, the tendency is this particular base component of our oil will also deplete. It will diminish through time. So that is now the time that we need to change our oil because remember, it's no longer the base quality or component that is being pumped through in our system, but already the acidic component, which could actually increase the chance of corrosion and oxidation in our system. Now, the opposite of base number would be our acid number. The acid number, also known as the TAN or the total acid number, is a measure of the amount of acidic substances in an oil sample or a fuel sample. It is expressed as a quantity of potassium hydroxide, KOH, in milligrams required to neutralize the acids present in 1 gram of the sample. So take note, this is quantity of potassium hydroxide to neutralize the acid. Monitoring acid numbers helps maintain engine health, optimize performance, plan maintenance effectively, and ensure compliance with environmental regulations. It is a valuable tool for ship operators to prevent premature engine wear and damage because it will require a lot of resources, labor, work, and money and time at the same time if we have damaged engine or machineries, ultimately contributing to the reliability and sustainability of maritime operations. Detergency would be our next chemical property, closely related to the addition of detergents, as we've discussed in our additives or our lubricant chemistry in the earlier video. It is the property of lube oil by which a lube oil resists deposit formation at key positions in the system. So this is mainly achieved by adding a specific additives to keep the system clean. And remember, detergency is actually adding to the base number. So meaning if we have base number, higher base number, then therefore there is also detergency. Meaning it will be also used as a cleaning agent in our system so that deposits will not easily stick to the surfaces. So as you can see here, soot particle is being enclosed or encircled by detergents or dispersants. And since they are heavy, they will just settle at a particular area, but not stick in the surface, since you can see here that we have the tails that are not attracted to the metal surface. It's only attracted to the soot, but never to the metal surface. That's why we need to change the oil in order for us to make sure that there will be no contamination. And we will be confident that the purpose of our lube oil is still functional, or the lube oil could still function as intended. So detergent C, these metallic additives, while allowing microparticles of metal or carbon to flow with oil, but resist them from depositing at any certain location, as what I discussed earlier. This plays a critical role in combustion space, as it flows them away from the combustion space, piston rings, and it goes. Because it will happen, or if it will happen, then our combustion operation will be at stake. So just to have a clearer picture of what is detergency, so we can also see here the iron or steel surface, and it's being repelled with, I mean, the water is being repelled with this particular rust inhibitor. And therefore, the surface will no longer be inflicted by any damage or deposits caused by our operation. So that's it for our video on the chemical properties of lube oil or lubricants. Don't forget to like, share, and subscribe. Thank you so much and have a great day.